The U.S. Interior Department has approved a permit for the world's biggest solar plant to get underway.
Yeah, California's got a goal of generating at least 20% of its power from renewable sources by 2020. The governor has said he wants 33% to come from renewable sources by 2020, so between 20 and 33%. But either way, that's a very ambitious goal.
He harvests wind. The turbine he sees from his living room window is his. It cost him $1 million, but the investment paid for itself within 5 years.
Olivier Chaloui of Mountain View, California still loves his Nissan Leaf in sun and in rain. As he passes gas stations posting ever-rising prices, Olivier knows he's saving money too. Charging his car nightly has raised his electric bill about $60 a month, but he pays monthly what many drivers pay weekly for gas.
As we advance further into the 21st century, we're beginning to see the need to renew rather than retire, reuse rather than discard, utilize rather than ignore. These are the types of activities and beliefs that are the basic ideas that embody the push towards renewable resources and energy. But are we really ready to rely on renewable energies? Right now, Americans account for only 5% of the population, the world's population, yet we consume 26% of the world's energy and produce 27% of the world's garbage. While some are not concerned about the alarming rate at which we consume energy and produce waste, others, including many businesses, are. In fact, Dell Computers recently began turning off their 50,000 computers at night and are now saving $1.8 million a year in energy costs. In 2011, Walmart reported that they kept 80% of all waste generated from their U.S. operations out of landfills and into recycling facilities, which returned $231 million to the business in that year alone. In addition, Walmart has over 180 renewable energy projects in operation or under development, testing solar, fuel cells, micro wind, off-site wind, and green power purchases. The technology to become a renewable and alternative energy society exists, but we need to develop leaders and technicians that understand how it operates. Luckily, tech centers like Tuscola Tech in Caro, Michigan are helping to do just that through a series of integrated, alternative, and renewable energy activities. In this episode, I will highlight some of the things that the students and faculty are working on in the area of alternative and renewable energies. I was at the 2013 Michigan Career Conference when I first heard of Tuscola Technology Center's interesting approach to teaching green energy concepts in the CTE classroom. While many career and technical centers were and are developing courses or sequence of courses that teach a specific type of green energy technology, Tuscola conducted a labor market needs analysis and determined that they could not justify doing the same. In other words, in the local community that they serve, there wasn't a large enough demand for green energy workers. So rather than not teaching green energy concepts at all, they decided to incorporate the technologies and ideas into many of their existing programs. In this video, I will highlight 4 specific programs and the green concepts taught within them. First up is the green cabin that was constructed by students in Bob Dice's construction technology program. While this cabin is not fully self-contained, it features a number of important green energy technologies and concepts. I asked Mr. Dice to explain some of the green features while we were in the cabin.
This is one of our projects that we spent about 18 months on, and we did different green energy tactics on this building. The building itself is 10 by 20. The electronics program was very involved. They did the battery backup system on it. The battery backups actually will run everything in the building that you see, such as the TV and the microwave, and some of the lighting is low voltage. The bathroom itself has a instant on-demand hot water heater. It's made by Bosch. It's very efficient. The hot water heater itself will heat several gallons of water a minute. This is our keypad. The keypad here, you can operate the different lighting and in different areas and there's also a loft in this building that the lights are operated on. The TV itself, the electrical, any type of the electrical components, and there's also some auto shut-offs set up on this. There's a trigger in our door jamb here, so once you leave, if you were to use this as a high efficiency type thing, there's a plunger right here located in the door jamb. This once the building has been non-occupied by motion, or this door has been closed for, say, whatever you want to set it at, like if it's 45 minutes, then it would self-shut itself down and maintain its battery charge for the next use. There's two 48-inch solar panels on the roof of this building. They will, in about 48 hours of daylight time, will give you about 10 and a half hours of charge. So you could say, like if you came up, if you had, this is like a weekend use building for you, you would take and you'd have like 2 or 3 hours a night of charge to use the lighting, maybe cook some food, do the dishes, that sort of thing. So we learned a lot of things on this project. One is that now that we've done it, we could, we could produce a set of electrical drawings. We kind of built this one as one of the first ones that the county centers were doing. So we were one of the first to start one, so there really wasn't a set of drawings, so we kind of built as we went, and then we went through some changes in our electrical department. The electrical system is very complex. For me as a builder, this would just throw most people a loop, but this is the control panel for this building, and as you can see, there's still slots to add and change things. The things that we would change with this is you could very well have the whole thing fully automated. The charging station is here right now. The batteries are removed. We're doing a replacement on those. Most of the things that we did do on this, there's something we probably would do different. And as far as the insulating and the green techniques we used, 5-star windows, 5-star energy glass. The appliances are rated with a 5-star energy appliance tag on them that you see at your home. The insulation was as much as we could put in the walls, and the ceiling is the same way. The ceiling has full air filtration with baffles and ridge venting, things you would do on an upper class home, I would say.
As you can see, the Green Cabin is an excellent way to teach Mr. Dice's construction technology students about constructing with green concepts in mind. If you would like this cabin, it definitely can be yours. The program is now accepting bids. Next up is an agri-science program headed up by Jeremy Glaspie. This agri-science program is utilizing worms, tilapia, and an interesting plant watering system to help teach renewable energy concepts. I first asked Jeremy to explain exactly why he has a giant bucket of worms in the back of his classroom.
All right, so when it comes to the renewable energies program that we're offering here, I think this is a little different take on recycling. What we have here is a vermicomposting bin, so we're raising these little red wiggler worms that basically they eat our food waste that we produce here in our cafeteria, our foods program, and what the plant waste that we have in our hydroponics. And so the purpose is, what we're just trying to do is, in vermicomposting, reducing the amount of space that we use in a landfill. So we're actually going to put the worms to work. They're going to be recyclers, and this piece of a leaf or this little piece of, this is a piece of tomato skin. So we actually had a whole tomato, and that's all that's left after the worms just devoured what was left of that tomato. So what these guys will do is they will eat the food waste that we have, or the plant material waste, and they'll rise to the top. And what we're looking to collect from the top of the surface is these worm castings. And worm castings is just it's a fancy word for worm manure. So we'll scrape the top of our vermicomposting bins, and so it'll be loaded with these worm castings. And that's where really most of the nutrients we're looking for to be able to utilize from this and our other systems comes from. And so we'll save these worm castings for later as a process of collecting worm tea what we're looking to do with the castings. And so to make the worm tea, what we would do is we took those little bit of worm castings, and what we're going to do is we're going to add water to those worm castings. And then it's a very simple process. All we're going to do is just shake those castings around, and we're trying to leach all the nutrients from the castings and put it in our water. Now we'll take what's resulting of this. This will be your worm tea. We will separate out the solids from the liquids, and our solids are going to go down in this nutrient stock tank underneath the lettuce table. On this stock tank, the water will get pumped from the tank up through the hoses down to the far end of the lettuce table where it's gravity fed down through the roots of the plants. And so if we take a look at our lettuce plants here, the lettuce plants have a root system that will follow the trail of water that comes from the pump. And so as the water flows, the roots will go in line with the water and just follow the water and the nutrients down the tray. This is what we call an NFT system, or nutrient flow technique system. And another one of our components of our renewable energy systems, actually a lot of this ties in with the hydroponics and food production on the Nagra Science end of it, is the aquaculture system. We currently have the capabilities of raising 300 tilapia from about 3-inch fingerlings to a full-sized 3.5 to 4-pound filleted fish. And so the purpose of the aquaculture program is, again, we use it to talk about water quality and water systems, but we will collect the nutrient-rich or nitrogen-rich water that these fish live in and use them to run through our hydroponic lettuce table and also through our hydroponic tomatoes, cucumbers, and peppers as an additional nitrogen source. And so all we're trying to do here is, our limiting factor in raising fish in a controlled environment such as this is the nitrogen. The nitrogen that they produce from basically going to the bathroom in the water, and the nitrogen that's produced in the water when we add food. And so the whole filtering system and understanding how we remove that nitrogen, it first goes through a bead filter which collects the solids, and we really like the solids because that's very nitrogen rich. All the solids will sink to the bottom of this filter, and every day we collect the solids. And that's really what we're pulling for our system. But as we look at this other big contraption here, we have a biofilter of sand and gravel and bacteria in this black tank. And so what the solids filter cannot get out of the system, as far as nitrogen, to remove nitrogen, the biofilter removes the rest. And so when we calculate it all out and we're moving correctly, this fish tank can remove, this filtering system can remove about 32 pounds of nitrogen a day, which is a good thing because when you're feeding 300 fish at their largest level, you're adding about 30 pounds of food nitrogen to the water.
Wow, who knew you could use waste from worms and tilapia to fertilize plants? Well, the students in Mr. Glaspie's agriculture course are learning that firsthand. Next, I'd like to highlight the Bolt. The Bolt is a Ford Ranger that was retrofitted with an electric motor. The retrofitting was a partnership between the welding and fabrication program and the electronics program. The end product was an all-electric pickup truck capable of doing 80 miles an hour with a range of 40 miles. I had Mr. Tim Loney, welding and fabrication instructor, explain the guts of the Bolt. Also, later, I had Mr. Paul Morris, electronics instructor, explain the batteries used to power the Bolt.
This was a pretty neat project to build. It took us about 4 months from start to finish to do this. This is one of those projects that actually everything went right on it. We didn't have to back up and start over. We did a little bit of research on this before we got started on it. We purchased what we thought was going to be a conversion kit to take out the original gas motor in this Ranger and put in this. And what came with was basically we had an adapter plate to go to the transmission, and we got a motor, and everything else was purchased separately as we went along. This was the students did a great job on this. They spent this was a complete student project with the welding instructor, myself, and Mr. Tinsey, the electronics instructor. For the welding program, what we did was we built all the aluminum plating that you see here on the motor. We adapted we pulled the water pump apart and we adapted that to be the idler pulley. And we wanted the air conditioner in here, so we had to modify the bracket that was on the air conditioning system to fit what we were building.
Those aluminum plates right there are the ones you fabricated?
The aluminum plates are the ones we fabricated. That's 1/2-inch aluminum. And underneath that, we had to make motor mounts to hold the motor actually to the frame of the truck, like it would have been in a regular gasoline engine. And everything that we worked on, we ran into where there was no vacuum, and you need vacuum to run the brakes. So we had to build a vacuum system in here. It's kind of like an air compressor, only it works backwards, and we got a little storage tank for vacuum. So when you turn it on, it builds up vacuum so you can run your brakes off of it. We still have the power steering pump.
Does it still have heat and all that stuff?
It still has heat. Like Mr. Morris was telling you, it has a heating element in here that gives you heat for your defroster, and not a lot of heat in the cab. We don't drive this thing too much in the wintertime, but we thought we better put that into it. Yeah, we had to do some modification on the suspension because it's got, like he said, it's got 12-volt batteries in the back, and it's quite heavy. So we had to put some overload springs in the back end of the truck just to get it to where it's set and rode very evenly. So it took a little bit of engineering. Some of the things that we didn't anticipate doing, like the suspension and stuff that as the project went on, like all do, we had to determine what we had to do next to fix that problem.
So this system uses a 144 volt system. It's 12 volt batteries. Each of these batteries is not a standard lead acid automotive battery. They're actually AGM batteries, which stands for absorbed glass mat. They are better for deep cycle conditions where you actually cycle the battery down. You run it a lot farther down than you would a standard car battery. They're not quite as effective as going to something like a lithium ion battery, which would work a heck of a lot better as far as taking a quick charge and being able to take a charge even though it's only halfway discharged.
As you can see, the Bolt is an excellent instructional resource highlighting the complexities of an electric vehicle. Speaking of electric vehicles, the next clip highlights the custom-built alternative energy go-karts built in partnership with the Welding and Fabrication Program, Electronics Program, and the PowerTech Program. These carts are capable of high speed as well as long travel distances. And each year they're put to the test at the Sanilac Alternative Energy Race. The rules of the race include that all go-karts must be powered by either electricity, propane, or diesel. Kendall, a power technology student, is currently building a go-kart to race in both the obstacle course and the drag race course at next year's event. I asked him to explain his project.
And all we did so far is bend out the cage, the roll cage, tacked it all together, and I got most of the welds done. Now we're just waiting on parts so I can finish knocking out the rear axle and the front steering and put the seat in there so I fit in there. And what we were planning on doing with it is racing it on the obstacle course, and then there's a drag race. So I kind of went in between with the height. So I have enough clearance for the bottom of the frame so it doesn't bottom out in the obstacle course, and then still be low enough so it's not top end heavy for the drag race.
And then what type of engine are you going to put in?
We're putting a 10 horse diesel on it, which also runs on biodiesel.
So there you have it, 4 of many alternative and renewable energy projects going on at Tuscola Technology Center. Some other alternative energy projects that they are experimenting with include wind, solar, and biofuels. If a technology center in the middle of the thumb of Michigan can do it, so can others, and in fact many are. Hopefully more can integrate these important methods and concepts into their curriculum. Our environment depends on it. I am Adam Manley. Many thanks to the teachers and students at Tuscola Technology Center for letting me take some time out of their day to make this video possible. And of course, thank you for watching.